Okay, the separation axioms follow from the replacement schema. I believe when the author says the separation axioms, he's talking about all of the axioms that you can obtain by selecting a formula phi and applying the separation schema. For this phi, according to the separation schema, if x is any class, I think is what's intended, and a constant p, then the collection of all elements in X that satisfy P is a set. That is essentially what the separation schema tells us. We would like to show that we could obtain this only using the replacement schema. The replacement schema says roughly that every function's image is a set. So we would like to use that to show that if we pick a phi, then for that phi and any class X, the subset or the elements in that class that satisfy phi is the image of a function. Oops, that's an error. Function should go here. So the task is, given a phi and given an x, we would like to find the appropriate function with that set as its image. The author gives us a very substantial hint, namely to take this particular function. So just to make sure that we know exactly what we're saying, we have to check that this is a function, and a function is a certain kind of relation, namely satisfying this little conditional property that, you know, essentially what this says is that if you have any two pair in the function with the same left coordinate, they must have the same right coordinate. That is to say, a left coordinate uniquely determines the right coordinate, right? No one thing maps to two distinct things. That's what a function is. Okay. Now, what is a relation? And this was kind of tricky to me, but I finally resolved it to myself, that there are two definitions of a relation in the book. One for sets and one for classes. You have to look in two different places in the book to see this. But here, because f is a class, we need to be using the class definition of a relation, and so that just says that a relation that is a class is one for which all the elements are n tuples. And here, certainly, all the elements are two tuples in the example that gives. Now, I would say that at this point, having checked that, subtlety, everything else is very easy, right? Checking that if you have two things with identical left coordinates, therefore they have identical right coordinates, is a trivial exercise at this point. Now, if we look at the image of this function on a set X, then of course, since the right coordinates all come out of X, then this will in fact be a subset of X. And in fact, because we require of this of these objects that they satisfy phi, then of course this image will contain all and only the elements that satisfy phi. So at this point, it has become a trivial exercise.